Hello everyone. In this video, we will see in detail about Travel Manager app. It's a Intel application. So coming next, the agenda. Yeah. So we will see the introduction, features, and how we can incorporate the sensors. And we'll go through a quick demo of a Travel Manager app. And we have a code walkthrough. And finally, we will come up with the conclusion. Yeah, coming to the introduction, Travel Manager app. So it's a Windows-based Ultrabook app. It's basically a WPF-based application, so which is essential when you are traveling or when you wish to know the route between two locations. That's the source and the destination. So it shows the map. So it's using a Bing map. With the help of a Bing map, we will be displaying the route direction from the source to destination. In addition to displaying the route, the app shows the road name, direction, kilometer to travel on all the major junctions and deviations. So this is just basically an additional information that we are providing as a part of this app. You can see the right side of the application. Yeah, application published in Intel App. So this is basically a screenshot which I have taken to show you how it looks. And this app uses a compass sensor with which one can see the north, south, east, west direction while traveling. And it also implements the light sensor. So light sensor is being used in this app, which is required when you are traveling at night when you can't expect good light. So basically, this app implements GPS, compass, and the light sensor. Coming to the features of Travel Manager app, we have on-the-road navigation with additional route information, and we can pin our current location. That's pin my current location uses a GPS sensor to get the latitude and longitudinal values. We have location tracking. So if enable, the app tracks where you are and updates map with the location. We have show compass, uses a compass sensor. We are enabling and disable light sensor is being used to change the map tile layer based on the luminance, and that's basically the lux value. So these are 5 major features that's provided as part of Travel Manager. Coming to the sensors to incorporate. So we are using, we are implementing basically the compass sensor. The compass sensor is being used to display a pictorial view of compass if required. And we have implemented the GPS sensor, so it is used to pin our current location in the map. So that's the pin my current location feature, and it is used to get the latitude and longitude value, and the app maps it accordingly in the map by showing a pumpkin in the map. So user can easily see his or her current location by looking at the pumpkin in the map. And also the GPS sensor is being used while in location tracking. So we have a concept of location tracking. So on enabling the location tracking, by just clicking on the location tracking button, the app takes care of the tracking location where you are by getting the latitude and longitudinal value from the GPS sensor, and pins a pumpkin on the map. As and when the user is moving, the map just updates with the location. We have implemented the ambient light sensor. Light sensor is being used in this app, which will switch the map mode from aerial mode. It's little dark green background to the road mode, like a white background. So it's based on the luminescence or lux value. We are switching the map modes. So basically, what we are doing is, so if the lux value is less than 100, the map mode gets switched from aerial to road mode. So this is basically um, a great advantage of using a light sensor. So our app basically, uh, here is the scenario where it switches the map background. So the user will be comfortable in using our app. So also we have touch screen capability and Bing Map control. By default, it supports the touch screen. We can easily zoom in, zoom out, or we can rotate map with fingers. So it's very convenient uh, approach. What I can say is, so we can just zoom in, zoom out, or do whatever is possible with the touch capability. So it's quite interesting to use the ability to use the touch screen which comes with the Ultrabook. Yeah, that's all about the sensors to incorporate. And so we have a quick demo of Travel Manager app. So what I'm going to do is quickly run from Visual Studio. Yes. So here you can see the Travel Manager app. So we have a from location to location. So basically we can key in our the location for which you would like to see the route. So basically what I'm going to do is I will key in location from location as Chicago and to location as Waukegan, and I will just click on show route button. It takes a while, so we can see the route. It's getting displayed here from Chicago to Waukegan. On the right side you can see the additional information about the route, how you can travel from Chicago to Waukegan. Take a ramp, keep right and keep left, and at last we will arrive from Chicago to Waukegan. I'll just click on pin my location so that we can see a pumpkin over here which shows my current location. I'm right now in South White Oak Drive. It's in Waukegan. And coming to start location tracking, I'm just starting the location tracking started. So as and when we are moving around, so the map gets so basically the pumpkin will move around, or the map gets refreshed, and the pumpkin is shown appropriately based on the current the latitude and longitude and value. I'm just stopping the location tracking, and we will go through the show compass. Yeah, so you can see here the compass is being shown. So it's a pictorial representation of the compass. You can see the northeast southwest direction. So what I'm doing here is so it's a static image just shown here. I can just move my Ultrabook around, so it calibrates and shows the direction. So we are getting a north headed value, or a direction north headed value, and we are going to rotate the image appropriately so that it shows the direction correctly. And so this is about the compass, and I'm just enabling the light sensor. Yeah, I can see the map background getting switched from the aerial mode to road mode. So I am in a place where I don't have much lights around, so it got switched from aerial mode to road mode. I'm just disabling light sensor, and we will be, yeah, so I'm going to default map mode. So map mode is defaulted to aerial mode. Yeah. So I can zoom in, zoom out, and just moving around. So this is all travel manager app. So we have seen the features, GPS, the GPS sensor, how it's being implemented, and we have also seen how we are used, or what is the real purpose of using the compass sensor. And also we have seen with the light sensor and usage. So yeah, that's all about travel manager application. Yeah, now we have code walkthrough. So we shall see the following things. Basically the architecture of travel manager and the code behind. So we'll see in detail how we have implemented the sensors and some of these things. How did we implement? Yeah, how did we implemented sensors? And we'll also look into the unit test. So we will quickly jump on to code walkthrough. Yeah. So this solution, the travel management solution, you can see it has three different projects. So it's the main travel manager app. It's a Windows presentation foundation, WPF based application. You can see the setup projects. I created this setup project using the install shield, and the last one comes the travel manager unit test. So you can see the unit test classes. Coming to the architecture, basically, yeah, coming to pattern, what I really used Here is the MEVM design pattern. The architecture is very simple with the core classes, the helper classes for GPS sensor, light sensor, and some of the other classes which we will be looking into. And we have view model, so it's a route view model. So we have a one main core route view model, so with which we will be getting the route information and the itinerary or additional information of the route which we are requesting. So some of the properties you can see the from location and the to location, and also we are using the Bing service. So I just referenced the Bing service. Yeah. So we have two observable collections, itinerary, directions. So the getting the directions and the itinerary, the additional information. On route view model, I'm just initializing the application ID. So it's a credential. So we are creating the application ID from the Bing portal. Yes, yeah, I'm encapsulating the methods to be called. So it's a I command, delegate command. So on calculate route and set current location. So we just encapsulating the respective methods. So we will look into calculate route, how the routes is being calculated. If we have a from and to location, so we are just checking from and to location. If it is empty, we will just throw an error. If not, so we are getting the geocoded address. What it will do is it will just call. So we are just creating a client, geocode service client, and we are setting credential and the query. Query is nothing but the query the address which we are looking. So the client dot geocode. We are calling a geocode method to get the location, and so we will quickly look into the calculate route. So here it takes two parameters, from and to geocode results, and we are creating instance of route service client. We're setting the credential, and we really want the waypoints. So we just converting the result whatever we have obtained from and to. So we are just adding the waypoints, and we are calculating the route. We just calling method calculate route with the request which has the waypoints, and we are getting the route result and the itinerary. It's nothing but the additional route information. And we are calling the get directions. This is how we are getting the direction to travel. We are just looping through itinerary, and we are getting the direction. Just adding the location. We are getting the location, and we are just adding the directions. So this is about the route view model. Coming to the helper classes, we'll quickly look into the geosensor. Basically, so this is the interface which I used. It's being implemented by the geosensor. One is the geosensor helper, and the other one is the IP-based geolocation. So initially, I didn't have an Ultrabook, so in order to test the application, what I did is I just faked a GPS sensor. So you can see here the IP-based geolocation, which implements geolocation. So it has a latitude, longitude, and some of the other information. So right now we are looking for how to get the latitude and longitude. So one has to just create an instance of IP-based geolocation and call a static method. What's my geolocation? So internally, what it does is it will create a web request to geoip2.com and setting the user agent. And once we get the response, what we'll do is we'll load the response. So we'll get an XML response. So we'll load into an XML document and we're just retrieving from the XML. We're getting an XML element. It's not null, so we will be getting the attributes: city, country, code, host, and the IP and latitude. And so we are really interested in retrieving the latitude and longitudinal value. So this method is very useful and is responsible for returning the IP-based geolocation. So in order to test the GPS functionality, so this is a very useful concept of faking the GPS sensor. So we will quickly look into the geosensor helper. So here you can see the way how we have implemented the geolocation, the geolocator to get the latitude and longitude value. So geolocator, so we are creating instance of geolocator, and we are registering the position change event which is required when we are changing a position. So we need to update the latitude and longitude. So we are just updating. We're getting the position and we are just updating the latitude and longitudinal value. So we have so on constructor of a geosensor helper, we are creating instance of geolocator and we are setting the position change. We are registering the position change event, and we have a method get geolocation. So basically, it internally it calls async method get geoposition async, and we will look through until the status is complete. So it's an async method, so we will wait until the operation to be completed. Once the operation is completed, we will be getting the results. So the position, the get results will return the position, and from the position instance, so we will be getting the coordinates and the latitude and longitude value. So this is about the GPS sensor, and we have a light sensor. With light sensor, what we are doing is we are creating a default. We are creating the default light sensor instance. We are setting up a timer so that it will update or it will fire the current luminescence value. This helper class, what it does is basically it encapsulates the light sensor logic, getting the luminescence value reading. So with this helper class, one can easily get the luminescence value in lux. We have a so following are the properties: minimum luminescence, desired reporting interval. So what we are really interested is getting the luminescence value in lux. So here's the property which returns which gets the current reading, the light sensor, and returns the luminescence value. And as I said earlier, we are using the timer start. So we have two methods, start and stop timer. So one is to just make sure when the timer is started, so that what we are doing is creating a default instance of timer, registering the tick event, setting the interval to be reported, and so on tick event, so it will basically fire a display current reading. So on display current reading, we are getting the current readings, and we'll get the luminescence value. We are just setting the luminescence value, and so here is the event we are firing. So one has to just register to the event. This is the event get current luminescence in lux event. So one has to register to this event. So we will be getting the luminescence value in lux. I will quickly show you the show compass they have been done. So some of the resource dictionary. So we need this information. The image. I'm using the compass image. You can see the compass. It's a static image. What we're doing is we have a compass image here over here, and the code behind, you can see what I'm doing here is yeah, I'm just setting, yeah, we're just creating instance of dispatcher timer instance, and registering the tick event, setting the interval, and starting the timer. So if we have a compass, that means so the compass will get default. So if we have a compass instance, that means so we can get the readings. Here we are setting the compass face, that's the image render transform origin. We're just setting the point, and we're just changing the angle, or we are transforming the image. So this here is the logic. So we are subtracting from 360 as the heading magnetic north. So we'll get the angle, and we'll just transform the image with the rotation. So that's how you can see the compass is being shown correctly with all the information, the north, south, east, west directions. And on timer click, basically this is required to continuously update the compass. Say you are rotating your Ultrabook, so in that case one has to get the current readings, um, and we are just updating, we are just transforming the compass image. So that's how you can see the directions correctly. And coming to the main window, there's nothing much we have. We're creating instance of geosensor, light sensor. We are setting the data context, the view model, and we are registering the error message event. If any error happens, we are just showing the error message. And we are initializing sensor, that's a light sensor, just disabling the buttons. If light sensor is found, just enabling the light sensor. We have enable and disable light sensor. What it does is basically it sets just on enable light sensor, you're just starting the light sensor. So it will continuously fire this event, light sensor, helper, current luminescence value. So that's how we are changing. What we're doing is we are just comparing the luminescence value, whatever we are getting from the event, with the minimum luminescence value, that's 100. You can see it over here, it's 100. So based on the luminescence value, if it is less than the minimum value, we are changing the being map mode from aerial mode to the road mode, and vice versa happens in the else condition. And we have logic say for pin my location. What we are doing is we are just using the geosensor helper. We are calling a get geolocation method. So we will be getting a latitude and longitudinal value. Then we are calling the add pumpkin to map method. So it will just map or it will just place a pumpkin over the being map. You can see the logic over here, getting the location, creating a new instance of the location, and creating a new instance of the pumpkin, setting the content and the location, and we're just adding the pumpkin over being map. And on location tracking, what we are doing is just displaying a message, and we are calling the timer instance. So what it does is timer instance, it will remove the previous one pumpkin which are is shown in the map, and it gets the current location and it calls the add pumpkin to map. So on location tracking, basically when you are moving around, so if it is enabled, it will show you the exact location with the help of a pumpkin. And the show compass, just creating instance of compass, and we're just calling the show dialog method. And so that's all about travel manager, and we have a class diagram over here. You can see the classes, IP based geolocation, eternity, and some of the other helper classes. We will quickly look into the setup project. So it's a new thing, or the install shield what we are using. It's something new in Visual Studio 2012. It no longer supports the default setup and deployment project. Microsoft has removed, or they are no longer supporting the setup and deployment projects. So this is the only option we have right now. So with the limited edition of install shield, I have created a travel manager setup. So it's very easy to use, and you can see the project assistant. Yeah. So coming to application files. So here you can just browse and add files. You can create a shortcut icon over here, and some of the other interesting thing. Yeah, we need to set the framework versions. And so it runs on Windows 8, so it's required. So .NET 3.5 is required, and the 4.5 package. So that's all about the setup project. So it's very easy to create a setup project with this. We will see travel manager unit test. So what I've done is I quickly reference the travel manager executable. So we will be getting all the the helper classes, access to helper class, view model, all this. So we will see in detail about the view model testing. So before looking into the unit test, I would like to tell you something why we really require the unit test. So why we really require is so one has to confirm the functionality whatever we are coding. So say you have completed coding of the road view model. So I have to confirm that we can't really wait until the whole application has been developed. So we will have to unit test or make sure it works as expected. So so here is a scenario where one has to verify the functionality of the view model. So that's a really great advantage what we are getting at the early stage. We are just we are confirming ourselves whether our view model, all the logics are working as expected, and also we can catch some of the bugs at the early stage of development. So one need not wait until the whole application has been developed. So we are using the Microsoft Unit Test framework based classes. We are creating a test class for testing the view model. And so on test initialization, we're creating instance of road view model, setting it from to location application ID, and we are just calling the calculate route command. So it's an I command. We will just calling the execute method so that it will call a private method which is encapsulated with this I command. So so that's all we are doing on init, and on each of these test method you can see um, the values being asserted. So you're just verifying the value assert is not null. You're just verifying the root result should have some value, and just checking the count root lex uh, root result dot lex dot count should be 1, and we are also confirming the root itinerary or the additional information of the root. And at last you can see here um, we are confirming the latitude and longitudinal value. So it's from Chicago to Waukegan. So you can see the latitude and longitudinal values, and one has to make sure. So this is a very important thing. One has to make sure your internet connection is up and running in order to run the unit test. So what I'll do is I'll just quickly run this unit test. Just right click and run unit test. Takes a while, and it should show the output. Yeah, you can see over here left side. Yeah, it shows the past unit test, past test 3, and we still have 2 more. That's for a different unit test. So all your unit tests have been passed. So that's how you can build confidence uh, in whatever you have implemented. So this is all about the roadway model unit test. So we will quickly look into the light sensor testing. So how we are going to test the light sensor. So we are creating instance light sensor helper, and we have a test method which confirms the value of the luminescence. What we are going to do is we are getting the luminescence or lux value, at least it should be greater than 0. So if it is less than or equal to 0, that means there is something wrong with the light sensor. Uh, so we need to check our implementation in that case. So we are just asserting the true or failure condition for a light sensor. and nothing much we are doing or light sensor, and we have geo sensor helper. So how you are going to just test the geo sensor is so on test init initialization we are creating instance of a geo sensor helper, and we have a test method over here. You can see we are calling a get geolocation. So it gets the latitude and longitudinal value, so that's being set in the property, and we are verifying the same over here. It should not be null or empty, so that's how we confirm the latitude and longitudinal values are being. So that's all about the code walkthrough. I hope you understood something about the travel manager app from the code walkthrough, and we'll go back to the presentation here. So we have completed the code walkthrough. Coming to the conclusion part, I hope you have understood about the usage of sensors in real-world scenarios with the help of Travel Manager app. And also in today's world with touchscreen tablets or Ultrabook, developers can incorporate and take advantage of these sensors. And the Intel app, so it's really a great platform for developers showcasing their app which implements sensor capabilities. It's a good time for us to learn and contribute to the community. And that's all about the travel manager. Hope you guys enjoyed the video. Thank you guys. We'll see you in the next video.